Welcome to lesson number 4 and our focus on density. Our objectives for this lesson: determine the volume of a substance and then calculate density, mass, and volume. Recall that mass is the amount of matter an object contains, and this is very different from weight, which is mass plus gravity. And we use the electronic balance in class to measure mass of an object. The volume is the amount of space that substance occupies or takes up. So how do we measure volume? Well, it depends on what the substance is. If it's a regular solid like a cube, we could use length times width times height. So in this example here, if it's a cube, each side is 1 centimeter. So 1 centimeter times 1 centimeter times 1 centimeter gives us a volume of 1 centimeter cubed. If it's a liquid, we can use a graduated cylinder to measure the volume. And we read the bottom of the curved line, which is called the meniscus. So in this example here, the volume of the substance is 27.5 milliliters. So for volume, you may see units in liters or milliliters, or you may see centimeters cubed. So it depends on if it's a regular solid or a liquid. And the conversion between centimeters cubed and milliliter is very simple. It's a 1-to-1 conversion. So 1 milliliter is equal to 1 centimeters cubed. So how do we read the meniscus on the graduated cylinder? This is really important, especially for our lab investigations. You want to make sure that you're reading it properly, otherwise you're going to have a lot of error in your measurements. So first thing you do is you place the graduated cylinder flat on the table, and you want to make sure that you're not reading it too high or too low. If you are reading it too low, if you're below eye level, the line of sight's too high, and you're going to be off by approximately 1 milliliter or more. And the same thing, if you are too high, your line of sight becomes too low, and you're off the same amount in the opposite direction. So what you want to do is to make sure that you are eye level with that meniscus. You read the bottom of it, and you'll get a correct reading of volume. How do we measure volume then of something that's an irregular object, like a sphere or some other irregular object that we're measuring in class? Well, we use something called water displacement. And it's really simple. You place a known amount of water in the graduated cylinder. So here we have 4 milliliters. We drop in our objects, and they were going to displace, because they take up space, they have volume, they're going to displace the water. And the amount of displacement is the volume of that object. So what we do is we take the final volume, in this case it's 6, minus the initial volume of 4, and that's going to give us a volume of 2 milliliters. So that's the volume of these objects. Let's check your understanding. Can you determine the volume of a substance? So now let's look at density. Now, density is the ratio of mass of an object to the space it takes up, the volume. So if you look at these two boxes here, they are the same size boxes, so they have the same volume. And let's assume that these circles represent our atoms or particles, and they're the same. So let's just say this is sulfur and this is sulfur. So what's the difference? Well, I have more particles in this space. Okay, so if I have more particles in the same amount of space, that means, and they're the same particles, that means I have more mass in this amount of space. If I have more mass in the same amount of volume, then box A would have a greater density. So density measures that ratio of the amount of mass in the space it takes up, which we call volume. And the calculation is density equals mass over volume, and that's on table T on the back of your reference table. So you'll be required to do some density calculations, which you've done in previous science courses. I want to make a statement. I want you to avoid, if you learn the density triangle, avoid using the density triangle. And here's the reason why. As the year progresses, we'll get into more and more complex calculations where you have to know how to solve for a variable on either side of an equation. And so it's better to learn it now doing density, which you've done before, than try to learn it later in the year when we're doing more complex calculations. All right, so how do we solve for a variable? All right, so what is the density of an object with a mass of 60 grams and a volume of 2 centimeters cubed? So if you're given a problem, first thing you have to do is figure out which formula are you using. So in this case, it's pretty simple. They say density. But if it didn't say that, if you were lost, look at the units. We have grams, which is mass, and we have volume, which is centimeters cubed. So if you go on your reference table on table T, find a formula that has mass and volume in it, and you'll see it's the density formula. So the first thing we do in any calculation this year is going to write out our formula from table T. So density equals mass over volume. And now what we're going to do is we're going to place the measurements in the appropriate spot on the formula. So we have mass, grams, that goes on top. And then we have volume, centimeters cubed, that goes on the bottom. And now we simply divide 60 divided by 2, which gives me 30. And don't forget our units here. So it's grams divided by centimeters cubed, so grams per centimeter cubed. Let's see another example. An object has a volume of 825 centimeters cubed and a density of 13.60 grams per centimeter cubed. We now want to find its mass. So we still use the same formula, but now we're solving for m, our mass. So we're going to place our values where they belong. So the density 13.60 goes here, and the volume 825 goes on the bottom here. And we set it up just like this. So now, how do we solve for this variable on the other side of the equal sign? What we do is we place this over 1, and now we're going to cross multiply. And I would suggest actually even rewriting this next step. So 1 times x is x, and then 13.60 times 825. And that's going to give us an answer of 11,220 grams. We notice that centimeters cubed cancels out, and we're left with what we're solving for, which is the mass in grams. How do you solve now for mass or volume if density is not given? So you end up with two variables, which we can't have. So density of all our elements are actually listed on table S, which is in the center of your reference table. So here's an example. The volume of an aluminum sample is 251 centimeters cubed. What is the mass of the sample? So we're solving for mass. We have volume, but we need density. So we look up on table S, and we'll find that the density of aluminum is 2.70 grams per centimeters cubed, which you can see here. So here's table S. We find aluminum, and we go to the density column, so 2.70 grams per centimeter cubed. So now we have our density. We have our volume, which is this 251, so now we can solve for mass. And we set up the formula just as we did in the previous example. We solve for mass by setting this over 1 and cross multiplying. And we get an answer of 678 grams. Always check your work. So if you want to see if this is correct, plug it back into the formula. So put 678 on the top for mass, divided by 251, and it should give you 2.70. Let's check your understanding. Can you calculate density, mass, and volume? At this point, you should be able to determine the volume of a substance, as well as calculate density, mass, and volume.